All right, guys, for today, we are going to move on to another method of solving. Yay! Can everything be factored? Can you factor every problem that you come across? No, you cannot. So what we are going to do is look at some other options. These other options will also be used all the way through the rest of the semester. So, do you guys notice something about what I'm passing out to you right now? It's a colored paper. You can use it on your exam. Yay, we like colored papers. All right, so on the colored paper, we are going to kind of use this to kind of organize our thoughts on the different methods. So the first method that we use to solve quadratic equations, what's quadratic mean? What? It does not mean 4 parts. Quadratic equations are x squared. So these are methods used to be solving anything that is an x squared. That's what quadratic means. Okay, it's an x squared. So our first option that we've been working on is factoring. We know how to factor, right? So when you're factoring, what was the first thing you have to do with the problem? Before GCF. Oh, man. You need to set the equation equal to 0. Set the equation equal to 0. Then your first rule of factoring is look for a GCF. Then you would just factor completely, whatever that entails, depending on what kind of problem it is. And then we set each factor equal to 0 and solve. Yes? Good? Based on your quizzes that you guys took last week, which we'll look at those in a little bit, you guys did very well with factoring. Okay? We did very well. I was very happy. Now, today, we are going to work on square root method. Love this method. It is like quick, fast, love it. However, people make very simple mistakes. Sorry. We also have completing the square. You can actually cross this out. This is another method, but I only have you guys for one semester. And based on what's important and not important that you need to know or don't need to know, that's in the not really need to know category. Yeah. On the SLO? Oh, on the pretest? If it was still on there, it shouldn't have been. So I will take that into consideration when I check those grades on those. And then quadratic formula. Do we know the quadratic formula? Negative b plus or minus square root. No, not. B squared minus 4ac all over 2a? No? Okay. That's right. We'll get to that. But today we're going to focus on the square root method, so we'll come back to this page here in just a minute. There we go. All right, so solving by finding the square roots. You can only solve a quadratic equation by finding square roots if there is no blank term in the equation. So we need to be missing the bx term, right? Because remember, it's ax squared plus bx plus c equals 0. You need to be missing that plain x term. All right, so which equations are missing the bx term? So I got 4 equations there. Which ones are missing the bx? Is the first one? Yeah. Right, it's got the ax squared, and then the c part just kind of split, right? I can move that. All right, is this one missing it? No, it's right there. So that one's not missing it. This one? No. This one? Yeah. So if it's missing the bx term, I can use the square root method. There's an x right there. All right, so to solve by finding square roots, you will isolate the x squared, then take the square root of both sides of the equation. This is why yesterday one of the things I left for you to do was simplifying radicals, because we need to make sure we're remembering how to do that. All right, so back on your colored paper, square root method. Let's kind of jot some things down here, okay? So it must be missing the bx term. So let's go ahead and put that right there at the top so I don't forget. In order to use this method, it has to be missing the bx. If it has a bx, I can't even think about using this method. All right, so it must be missing the bx term. You're not setting them equal to 0 in this one. You will isolate the x squared. So in other words, you want it to be x squared equals a number is what we're looking for at that point. Right? You're getting the x squared term by itself. It doesn't have ax squared equal to number. It's just x squared equals a number. So if there's an a value, you're going to have to divide to get rid of that. Okay? After you isolate, you will take the square root of both sides. And then the part everyone always messes up on, don't forget the plus minus. Because when I take a square root of a number, do I get one answer or two? I get two. What's the square root of 25? Positive 5 or negative 5. Because 5 times 5 is 25, but negative 5 times negative 5 is also 25. So you actually get two answers when you take the square root of something. Right? So don't forget your plus minus, and then solve for x if necessary. And we'll look at some today where that happens. Okay? Seems pretty simple, right? Get the x squared by itself. Then I take the square root. Make sure I have a plus minus there. And then I just get x by itself if it's not. Sound easy enough? Yeah? Awesome. Let's try it. All right. So on here, I have x squared minus 25 equals 0. Okay? So I'm missing the bx term, right? So I need to get the x squared by itself. So we'll have to add 25 to the other side. So x squared equals, when I move that over, becomes positive 25. Once x squared is by itself, we take the square root of both sides. What's the square root of x squared? That's just x. Square root of 25? Or negative 5. So this is plus or minus 5. Look, I just solved. Wasn't that fun? Now, I do want to look at this another way, just because this problem is nice, that I can also do this problem by factoring. Factoring we set equal to 0, which is already set equal to 0. What type of factoring is that? It's my favorite. How does that factor? X plus 5, x minus 5. So it factors. So then what would x equal here? Negative 5. And here x equals positive 5. So I solved the same problem two different ways and I got the same answer. What does that mean? It's correct, for one, right? It's correct. And it also means that it is okay to solve in more than one method. Now, some problems can only be solved by one method. Some problems can be solved by a couple methods. Okay, it just depends on what the problem looks like. But are we seeing why I have to have the plus minus when I took that square root, right? It does show up with 1 plus, 1 minus answer. Okay, number 2. X squared minus 12 equals 0. Right, it is missing the bx, so I know I can use this method. And I don't want to set equal to 0. I want to get the x squared by itself. So let's go ahead and add the 12 to the other side. All right, once the x squared is totally by itself, we will take the square root of both sides. Square root of x squared is just x. What's the square root of 12? It's not pretty, right? Ugly. Good. Remember our factor trees? So I get 2 and a leftover 3, so 2 radical 3. And what are you not supposed to forget? Plus minus. Now, I think we briefly kind of mentioned on it. If my problem is an x squared, how many answers will you have? I will have 2. So if you forget the plus minus, you've literally forgotten half of your answers. You've only given me the positive one. All right, what about number 3? What do you want to do with that one first? You got some options. Add x. Why would you add the x? Makes it so much easier, right? Makes that positive. So I move that, becomes x squared plus 6. Then subtract the 6. So x squared equals it's 27. Need to wake up those brains this morning, guys. All right. X squared, no. X squared is totally by itself, so we'll take the square root of both sides. So x equals square root of 27. Very nice. Again, that's a factor tree for those of you. Make sure you have a pair of 3s, leftover 3, and don't forget your plus minus. I've had kids on their quiz over this who should have had A's ended up with C's because they forgot their plus minus signs. I know, right? What are you going to do with these kids? Right? They're probably, you're right, the ones who forget the baby brother as well. All right. Number 4. What do you do there? What do you do on number 4? Good. Minus 9. So 2x squared equals 4. Good. The other mistake kids make all the time, they're like, yeah, I'm good. I can take the square root of both sides. X squared is not by itself. I don't want ax squared. I want just x squared. So divide by 2. So x squared equals 2. Then what? Get square root of both sides. So x equals just square root of 2. Plus or minus. I should have 2 answers. Yeah, and I can't do anything with a 2. I'm just radical 2. But it'd be wrong. How are we feeling so far? Okay? All right. How about number 5? What do you want to do there? Add the 5x squared. We can do that. So 5x squared, oops, minus 9. Okay, we moved over there. It's fine. Add 9. So 12 equals 5x squared. Good. Got to get that x squared completely by itself. So x squared, what do I do with 12 divided by 5? Good. Leave it 12 over 5. It's the beauty of improper fractions. I don't have to do much with it. Then what? This problem got ugly, didn't it? How do you take the square root of a fraction? Top and bottom. Right here is where people mess up. They just draw this giant radical over the whole thing, and then they forget that there's actually one on top and one on bottom. So make sure you write one on top, one on bottom. I still, to this day, will show my work, one on top, one on bottom. And I can do these in my head, and I still show it, okay? So don't forget. All right, square root of 12? Good. That's going to give me 2 radical 3. Square root of 5? I can't do anything with the 5, but I can't leave what? I can't leave a radical on the bottom. Gosh, you guys, can't leave that there. We have to rationalize. So what do we get on top? Over what? Over 5. Good, done, finished? Plus or minus? Plus minus. Do you guys realize what plus minus means, right? It means I have 2 radical 15 over 5, and I have negative 2 radical 15 over 5. It's 2 separate answers. We're just lazy mathematicians and just write plus minus on it. So do we see how what we've done in the past continuously keeps coming back? Sadly, yes, it keeps coming back, right? You were liking this method until I did that one, huh? All right, why don't you guys try number 6 on your own? Number 6. All right, guys. So number 6, boys. So subtract 7 first. So 3x squared equals 16. Divide by 3. One thing I noticed, a couple of you kind of got yourself stuck. You did the big giant divide by 3. And then we're not sure what to do with that. If you show it underneath each part, I think it makes more sense. That cancels, and then you can be like, well, that doesn't divide, so it's just 16 over 3. Okay, so just be careful. Some of your shortcuts are going to hinder some of you more than help you. Then we take the square root, fraction, so it's top and bottom. So we get x equals, square root of 16 is 4. Square root of 3, I can't do anything with, but can't leave a radical on the bottom. So we get x equals 4 radical 3 over 3, and don't forget your plus minus. Good. Overall, you guys look pretty good walking around. Yes, problem. All right, number 7. Problem looks very similar, right? Just a couple tweaks on some numbers. So number 7, if we subtract 19 first, because when we're solving these, we need to make sure we're getting the x squared by itself. That gives us negative 16. Right? Isolating the x squared, we will divide by 3. It looks very similar to what I had before, but it's different. Because what happens when I take the square root of this? Yes, you get imaginary numbers. So that's going to be 4i over radical 3. So we got to remember those rules. When there's a negative underneath a radical, your answer has an I in it. Okay? Have to rationalize. Get out of the way. Move. He's not being nice to me. All right, so we have to rationalize top and bottom by radical 3. So 4i radical 3 over 3. And then don't forget your plus minus. All right, so be aware that those i's are going to pop up again from time to time. How are we feeling so far? All right, so why don't you guys try 8 and 9? All right, guys. So number 8, add 2 to the other side. So 4x squared equals negative 15. Divide by 4. That does not divide, so it stays a fraction. A couple of you are writing your fractions slanted, right? Like the big old slash. Don't do that, okay? I know when you're younger you probably did that all the time, but we want up and down fractions. That way when we take the square root, we can clearly see top and bottom separated. So x equals, what happens on the top? I. So I radical 15. 15 won't break down, and the square root of 4 is 2. So I'm good? Yay? Plus minus. I already caught a couple of you forgot the plus minuses already. No, we just started. All right, and then number 9, subtract the 27. So x squared equals negative 24. Take the square root. So x equals, what do we know about the negative? It's going to be an I. And then 24, we want to go ahead and break that down. All right, so we get a pair of 2's. So 2i, and then we have left over 6. Good? Plus minus. If I throw that at you enough and yell at you, maybe you'll remember it. Why did I make the what? Oh, I make my 2's different all the time. I don't know. All right. All right, guys, the other part of this, still square root method, but it looks slightly different. So do you see a parentheses squared? Yeah? So, I mean, in theory, could I think of this as a giant x squared? Right? So would you say then it is isolated? Yeah. So anytime you have a big parentheses squared, just think of that as a giant x squared. Don't try to distribute and multiply that whole thing out. You're going to turn into an ugly mess, okay? So all we have to do is isolate the x squared, or the parentheses squared, and it's going to work the same way. So now when I take the square root of both sides, what's the square root of x minus 3 squared? It's just x minus 3. Because what's the opposite of squaring something? Square rooting something. Yeah, they cancel each other out. And what's the square root of 49? So plus or minus 7? Okay, so the other thing I need to talk to you about is where does the plus minus go? Because some people like do their whole problem and they just slap a plus minus on the end. Wrong. All right, the plus minus is the answer to the square root. So when you take the square root of something, its answer is where the plus minus goes. So now, though, when I go to solve this, this is where on your step-by-step I said to solve for x if necessary. X is not by itself. Now, I'm going to write this slightly different just because I think that helps people. But when I move a negative 3 over, it becomes positive 3. If I write it this way, for whatever reason, this tends to help people out to see it better. What's 3 plus 7? And what's 3 minus 7? Negative 4. Okay, so what happens is a lot of people, when they write just, if they write plus 3 underneath here, they're like, yeah, it's plus or minus 10. No, it's not. Okay, I just think that it helps to see it when I kind of just bring it over this way and write it in front. It makes more sense to people. Plus minus means I'm adding and I'm subtracting. It means I'm doing two operations. Okay, what about number 11? What will I have to do with that one first? Good, divide by 2. I still need to isolate the squared part. It's just a parenthesis this time. So I have y minus 1 squared equals 25. The parenthesis squared is isolated. Do not multiply that thing out. Okay? So that means I will take the square root of both sides. The square and the square root just cancel each other out. And the square root of 25 is what? Plus or minus 5. I know it's hard to get used to that. Square root plus minus. Square root plus minus. They just kind of go hand in hand. And then to get y by itself, I'm going to move that over there. What happens to the negative 1 when I move it? Positive 1 plus or minus 5. Good. 6 and negative 4. Right? Because 1 plus 5 is 6 and 1 minus 5 is negative 4. So are you still getting two answers? Yeah. Where does the plus minus go? After I square root it. Doesn't mean do the whole problem and slap a plus minus on the end of it. Okay? Wrong. Now, do our radicals always come out nice and pretty like this? No. No, they don't. All right, so number 12. What do I do with that? Divide by 3. All right, so we get x plus 2 squared. 30 divided by 3, 10. Okay, I got the parentheses squared isolated, so we will take the square root of both sides. The radical and the square will cancel each other out and leave just x plus 2. Square root of 10. Square root of 10. But don't forget your plus minus, right? You need to recognize the plus minus attaches to the square root symbol, okay? Or when I take the square root of something. And then to get x by itself, the positive 2 becomes negative 2 plus or minus my radical 10. Now on the previous problems, I went ahead then and added and subtracted. Can I add and subtract these together? They're not like terms. So these are actually even easier. I'm done then. So if you're left with a radical or an I, because that's going to make them not like terms, you're done then. Now if it's just numbers, you need to put them together. What about 13? What do I do that 1/3 in front? Lou? Good. I can multiply by 3. What else could I do? I could divide by 1/3. Is that not the same thing? Yeah. No, I love that you knew that to multiply by 3. Most students do not realize that, and their go-to is to divide by 1/3, which is fine. When you're calculator dependent, I mean, it's fine. It works. But you are correct, Lou, that you are multiplying by 3. So what is 7 divided by 1/3? It's just 21, because I mean, it's the same thing as 7 times 3. It's 21. Okay, so don't, again, fractions, should we panic? No. No. Maybe if I took your calculator away, you would. Square root of both sides. It's going to cancel out that square, so I have just x plus 5. Square root of 21. Square root of 21 plus minus. And then to get x by itself, okay, we're going to minus the 5. Can I put those together? I am done. Now, the question always comes up, do I have to put the minus 5 in front? Do you have to? It looks better, kind of like 4x looks better than x4. The main reason I will tell you right now that I do this, if I would have plus or minus radical 21, and then I put the minus 5 like this, one, it looks weird. But what happens if my radical gets a little long? And that gets over top of that, even the slightest, that means it's underneath. That completely changes your answer. Okay, so if we throw it in the front, there's no doubt that it's not part of that and stays separate, which is why I don't recommend putting it in the backside. Okay? Number 14. We do that. Good. Subtract the 13. We're just still going to isolate this. Subtract 13. That makes negative 9. Then what? Take the square root. X minus 3 equals, what's the square root of negative 9? 3i. Just 3i? Plus or minus 3i. You took the square roots, plus minus. And then to get x by itself, negative 3 becomes positive 3 plus or minus 3i. Are those like terms? They are not. One has an I, one does not. So if it has an I or a radical, you're done. Okay? If there's no I, there's no radical, you better put them together and tell me what those answers are.